morning, algebra students. Today we are going to be solving compound inequalities. These are inequalities that have more than one part. Your goal is to learn how to solve these inequalities and to be able to graph the solution set to these inequalities. So get your highlighter and highlight with me. What is a compound inequality? A compound inequality is an inequality that is joined with the words and, or. So fill those blanks in with your pen. So an example of an and inequality is here. 3 is less than 2x minus 4, and 2x minus 4 is less than or equal to 6. And go ahead and highlight, means that the solution set makes all parts of the inequality true. And when you solve these and inequalities, you're going to end up shading in a part of your number line that kind of looks like a barbell. You're going to have your two circles, open or closed, and an area shaded in between. An or inequality, on the other hand, is always joined by this word or. So you have to look for that word. Here we have 2x minus 4 is less than 5, or negative 3x plus 7 is less than negative 15. So again, highlighting. Or means that the solution set will make one or the other true, not necessarily both. And with an or inequality, you're going to end up shading in two opposite directions. So it'll look kind of like this. And Ms. Turner says that you can think about this as oars on a boat. You've got your rowboat and you're paddling with your two oars. All right, so we're going to look at solving a couple of compound inequalities. So first we're going to look at solving an or inequality. So circle the word or. For an or inequality, you will see the word or every time, which is pretty nice. You have to solve both parts individually. You don't get to pick which one to do. So highlight along with me. You'll solve each individual inequality just as we've been doing for simple inequalities, remembering to switch the sign when you multiply or divide by a negative. And then you'll graph each of your solutions. The final answer will be the entire graphed area. Your answer might have the words or in it. So let's do an example. On your next page, you have this inequality. Solve and graph 5x plus 1 is greater than negative 7, or negative 10 is greater than minus 7 plus x. So we've got that magic word or, and that tells us that we're going to solve them individually. So I'm just going to draw this kind of dividing line to show that these are two different math problems that we're going to do. So first we'll do the one on the left. 5x plus 1, I'm just going to rewrite it, is greater than negative 7. So we want to get the x alone. So first we'll subtract 1 from both sides. And you should be following along on your paper. We'll want to see this algebra. So on the left, we'll end up with 5x, because these ones cancel out, is greater than negative 7 minus 1 is negative 8. And then we'll divide by 5, and you'll get x is greater than negative 8/5. You can math frac it, and you'll see that that's the lowest term. Or you might want to check and see what it is as a decimal, just to help you with number line placement, and it is negative 1.6. So that's one of our math problems. Now let's do the other one. This inequality is negative 10 is greater than negative 7 plus x. So here we'll have to add 7 to both sides to get the x alone, which will give us negative 3 is greater than x. And now we're all done. This was kind of nice to have it be shorter than the other one. Negative 3 is greater than x. But I'm actually going to write it the other way because I like putting the x on the left. So now we'll graph the two inequalities. X is greater than negative 8.5, think we'll put -8 here. I'm going to put my 0 in because I like having my 0. And x is greater than -8 fifths. -8 fifths is not included, and we're going to shade this way. And then -3 will be down here. It's less than -1.6, so it'll be further to the left. This one is also not included, and we'll shade that way to show that x is smaller. So we have two different parts shaded, just like the oars of a boat, going in two different directions. So pause if you need to. You should have all the algebra on your paper, and you should have the shaded, labeled number line. And then when you're ready, join me, and we'll solve an and inequality. So for an and inequality, I'm going to circle the word and. Most of the time, you do not see the word and. You'll just see an inequality with two inequality signs. To solve the and inequalities, you'll add or subtract 3 times, then you'll multiply and divide 3 times, and I'll show you what we mean. And once again, remember to switch all the inequality signs if you multiply or divide by a negative. That's still true. Once you're done, you'll graph each of your solutions. And your answer will be the part of the graph that falls between. The answer will usually look like a number is less than x, is less than another number, or some variation of that. So here's our example. I think it's on your next page. Solve and graph -10 is less than 5x plus 2 is less than 3. So here we have the x in the middle between two inequality signs. And I'm going to go ahead and do my dotted line like we did in the beginning for solving equations, just to show the three parts of this equation. So 2 dotted lines, and go ahead and do that if you would like, because I think it could be helpful. So we want to get the x alone. So just like all the algebra we've been doing, the first thing we're going to do is subtract 2. And now we have to do it 3 times, once on each part of each inequality sign. So here on the left, -10 minus 2 is -12. I'm going to draw my less than sign. In the middle, the 2's cancel out, and we have 5x, and less than again. And on the right, 3 minus 2 is 1. Okay, next, to get the x alone, we'll divide everything by 5. 3 times, we're going to divide by 5. Check if you want. -12 divided by 5 is just -12 fifths, is less than x, is less than 1/5. So we have x in between two numbers, and so we'll draw those numbers on the number line. Go ahead and draw in a number line. 1/5, and again, I'm going to put 0 in just so I know where things are. And here's -12 fifths. And then we'll shade. We have less than, so our numbers are not included, and x lies in the middle. So we have our barbell shape here. Make sure you have the algebra. Make sure you have your number line. And that is the example of how we would solve an and inequality. All right, so now we're going to do some matching. You have these 4 numbers on your paper, and we're going to match some graphs to each of these examples. So the first one we have is choose the correct graph that matches the phrase below. All numbers that are at most 3 or at least 5. And so here we have our magic word, or, and that tells us that we're going to have those shadings that go off in the opposite direction. So we can eliminate this first one. And then we just need to decide if our points are included or not. So at most 3 tells me that 3 is included. It can be 3. And at least 5 tells me that 5 is included. So we will have this one here with 3 included and 5 included. So I'm going to drag it up here. But for you, you can use a number line. When you draw your number line in, all you have to do is draw in the numbers 3 and 5. You don't have to have all the other numbers. But then go ahead and shade with your solid circles, shade out in both directions. So draw that number line underneath number 3 here. Next up, we're going to do number 4, above 79 but less than 74. Today's temperature will be above 79 but less than 84. So since we don't have an or, this is going to be an and, which means we'll shade in the middle part. So we'll cross off these two. So now the question is, do we have 79 and 84 included? So above 79 tells me that 79 is not included. So we'll have an open circle there. And similarly, less than 84 tells me 84 is not included. So we will have this one here with 2 open circles and the area between shaded. And again, when you draw it on your paper, all you need to have is the 79 and the 84 actually, and the number line and the shading. You don't have to write in all the other numbers, but we do want to see the picture underneath 4 that matches the description. All right, 2 more. All numbers that are greater than -6, but no more than 3. And here too, we don't have the word and, so we know that this will be, we don't have the word or, so we know this is going to be an and we know we'll be shading in the middle. So we'll eliminate the last 2. I love being able to eliminate solutions. Greater than -6 tells me that -6 is not included. No more than 3 means it can be 3. It just can't be bigger. So we're looking for the open circle at -6 and the closed circle at 3. So here we have it. So that one matches here. And go ahead and draw in your own number line. All yours needs to have on it is the -6 and the 3 with the open circles and the shading in between. All right, one more when you're ready. Last example. Choose the correct graph that matches the phrase below. All numbers that are at most -1 or more than 4. Oh, so we've got that word or again. So or tells us we're going to be going off in 2 different directions. So let's cross off the last 2. At most -1 means that -1 is okay, so we'll include -1. More than 4 means 4 will not be included. So we're looking for a closed circle at -1, open circle at 4, and here it is. So let's move that one over here, and you draw in your own number line. And when you're done, you should have these 4 examples with shaded number lines to match. Thank you for taking some notes with me today.